of general relativity. Right in the beginning, I had said the equivalence, which essentially says non-uniform as well as time-dependent gravity is, you can always choose a sufficiently small reference frame for sufficiently small time in which the gravitation simply disappears. That means in this small local reference frame for a short time, the geometry inside is the Minkowskian geometry. Meaning what? Remember, I had mentioned that in special relativity, the square of the proper distance is given by c squared times square of the difference in the time of the events. From that you subtract the square of the Euclidean distance. Now, what principle of equivalence says is in any kind of gravity or any kind of curved space-time, you can always choose a sufficiently small reference frame for sufficiently small time such that inside the square of the proper distance is given exactly by the Minkowskian prescription of evaluating the square of the proper distance. In other words, the relation between the principle of equivalence and non-Euclidean geometry in the case of gravitation is principle of equivalence says that you can always choose a freely falling reference frame which is sufficiently small, then for small enough time in this freely falling reference frame, gravity disappears. While the choosing of local inertial frame in any curved space-time means that you can always choose a coordinate system in a small enough region for a short duration such that the square of the proper distance is given by the Minkowskian prescription. Of course, we know that when the reference frame is large or for longer duration, the curved nature of the geometry shows up. And essentially it is due to the fact that when the gravitation is non-uniform or time dependent, there are tidal forces. We know that even Newtonian gravity predicts tidal force, because if you have sun as a gravitational source, then the gravitational force due to sun goes as 1 over square of distance from the system. So the point of the earth which is closer, while the point which is farthest from the sun is falling towards the sun at a less amount of acceleration, because of which there is a tidal bulge. That means the ocean which is closer to the sun, it gets bulged towards the sun, while the portion of the ocean which is diametrically opposite or the antipodal point bulges towards the direction which is away from the sun. And this wave is essentially coming about because the gravitation due to sun is non-uniform. And Einstein's theory of general relativity, which is a relativistic formulation of gravitation, in such a theory